Okay, extends, interface, implements, and abstract. This may take some time. This may be split up into several videos. Let's start with extends. It's actually critical. We have to start there. It's used to establish an inheritance relationship. What does that mean? Well, every class extends something. And if we don't say that it extends something explicitly in our code, it is implied that it extends some class that is already written for us that's called object. So if in my code at the top I just say public class test class, that is exactly the same thing as saying public class test class extends object. Okay? And so if you don't type extends something, the computer essentially sees extends object there. It just kind of puts that in its eye, right? I mean, it's there if you type nothing. And if you type it, well, that's fine. This is just unnecessary typing. So what does it mean to extend object? Extend object, when you extend some other class, you establish an inheritance relationship between that class. So test class extends object. That it means that it inherits the public members of the object class. Now, since everything is an object, everything inherits the members of the object class. So we've seen a little bit of this without even realizing it. If I type in first dot, and I get this long list of members. Now, I can see some of the things that I created inside of test class. A, int. I created a method double me. I created a method print ID, right? We can see that I defined those things, right? I defined a public A and a public B and a public print ID and a public double me and a public print my values. And all those methods and variables, all the public stuff that I defined is available in this list, but I got a lot of stuff in this list that I never defined. Well, those were inherited from object. In fact, it even says in this list, object. That's the class that test class inherited it from. Just like you inherit things from your parents, test class inherits something from its parent. We say that object is the parent class, or sometimes they call it the superclass of test class. So object is the superclass, parent class of test class, and test class inherits all the public stuff that was defined inside of object. Okay? What does equals do? It returns true or false. If the two things are equal, it returns true. So I could say something like system.out.println first dot equals second. And it'll probably print false, because the two are not the same. Okay, yeah, it prints false. However, if I said first equals first, that should print true. Okay? Now, this is a little bit silly because I could have just said first double equals first and got the same result. However, when I say it's a little bit silly, it's not a lot silly, it's just a little silly. So the default behavior of the equals method, dot equals, is to test to see if two things are exactly the same, if they have the same address in memory. But we can change the behavior of that, and they do for the string class. So if I say string s, string s equals new string hello, and string 2 equals new string hello. If I say s double equals 2, that'll print false. But if I say s dot equals 2, that'll print true. Why? The dot equals method of the string class, the behavior has been changed so that it compares the characters of the string. But double equals for objects will always, always, always check the address of the object. And because I use the word new here, that tells the computer to create new memory on the stack. Or I'm sorry, on the heap. So we have in memory, we've got main method on the stack. It's got two variables, s and 2. When we call new, a new object is created. Memory is set aside for this new string. It's holding the letters hello. And then we create another new string holding the same letters. S double equals 2 compares the addresses. The variable s is holding the address of the first object, and the variable 2 is holding the address of the second object. Those two addresses are different because they're different objects. So s double equals 2 returns false, or evaluates to false. But the dot equals method of a string compares the characters in the string. And since they both have the same characters in them, s dot equals 2 evaluates to true. And sometimes what you want is to say, oh, are these two objects similar enough to be considered equal? Okay, well sometimes that's what you really want. And so we have a dot equals method to make a distinction between things that are similar enough to consider them equal and two things that are exactly the same address in memory. What do I mean by exactly the same address in memory? Well, it is entirely possible to make both of these variables point to exactly the same object. They would then both hold exactly the same memory. Excuse me, they would both hold exactly the same address in memory. How would I do that? Well, I assign one to the other. So if I had said s equals new string hello and 2 equals s, then the double equals is going to return true, and so is dot equals. Okay? There is another little weird quirk about Java. You notice that I didn't do this. Now this is perfectly okay. This is a string literal, right? So we've noticed that we can just type in strings inside of quotation marks. That string literal, when you use a string literal, Java sets aside memory for it, and it remembers it. So the next time you use the same string literal, it will reuse the same address in memory. If I don't use the new operator, then it won't create a new string. And so this will also print true for both methods of comparison. This is just an interesting little quirk of Java that is important to be aware of sometimes. So I got a little bit off track with the equals comparisons of strings. And I got there because all objects inherit the equals method. They also inherit the toString method, which is used for printing them out. They also inherit the hashcode method. And we won't normally use those without rewriting them in the subclass, but they are there. I can create a test class B. So extends is usually used to add functionality to an existing class. So say I wanted a test class B that did everything that the test class did and also did something else in addition. But I can't modify test class because maybe it's used in other projects or something. So what I can do is I can say test class B extends test class. So I've created a class. I've called it test class B. I've said that it extends test class. I've created a constructor for it that takes two parameters, just like test class did. And then I've said super, and then I've passed it the two parameters. What does this super thing do? This is calling the constructor of the super class. Remember, inside of test class, I have a constructor that takes two parameters, a W and a Q, and it assigns them to A and B. So in the constructor of test class B, because it extends test class, it needs a constructor, and it needs to call that constructor of its superclass. And then I have created a method, do something. This is an extension of test class. What does that look like in memory? Okay, so if I call the constructor of test class B, it will create an instance of test class. And that instance of test class has its own memory. It's like there's a little test class inside of test class B, and we access that little test class that's inside through the variable super. Okay? Because test class is the superclass of test class B. So now inside of main, I can create a variable, test class B, and when I try to access its public members, it has all the public members of object, all the public members of test class, and all the public members of test class B. So a subclass will inherit all of the public members of its superclass, and it's an easy way to add functionality to a class. I can create multiple classes that all inherit from the same superclass. So an example might be if you have a superclass of type dog, and you might have subclasses of type poodle, so an example might be that you have a class dog, and you might have subclasses poodle, dachshund, and terrier that all extend dog. There are certain things that all dogs are going to have in common, and certain things that are going to be specific to a poodle or a dachshund or a terrier, and you would put those specific things in the subclass and those things that they have in common in the superclass, and that way you don't have to rewrite the same code over and over in all of the subclasses. Another example, I'm using a little program to draw stuff at Paint. If I'm creating some sort of a drawing app, I might have a class called shape and subclasses circle, triangle, and square, so that any of the code that is going to be common to all shapes could be included in that shape class, and then the subclasses will all inherit it. Another example, we're going to create a Mancala game, and that Mancala game is going to have a class player. We will have a subclass of player that is a computer player. If you want a human versus a computer, you can have a subclass computer player and human player. That's not exactly the way that I structured it, but it is similar, and I do have a player and a computer player. There are lots and lots and lots of other examples. If you were doing something related to cars, you could have a class called car. Subclasses for the make. So you might have Ford, Toyota, Chevy, and you might have subclasses for Ford Taurus, Ford Focus, Toyota Camry, Toyota Avalon, Chevy Camaro. And so all of these things are cars. Certain cars are Ford. There are certain things that all Fords might have in common. I don't know. There are certain things that would be specific to a Taurus or a Chevy. So anyway, that's about classes. So that's the extends keyword. Interface, implements, and abstract I'll do in the next video. There is still a good bit more to say about this superclass, subclass relationship. There's a thing called polymorphism. There's overriding and overloading. Those are not keywords in Java, but it's words to describe concepts. Concepts that aren't even possible until you can have a superclass, subclass relationship. So we'll get to those in probably the next unit, not in this first unit, but please watch the next video. Learn about interfaces, implements, and abstract. We have used implements when we did implements mouse listener. Mouse listener is an interface, and so we've used it already in some projects, but we haven't really explicitly explained what those keywords mean and what they do. So please watch the next video. Thanks.